Hey guys, welcome to Mr. Bose's backyard. Here we are. I'm joined alongside with my puppy dog. Say hi, Bogey. You want to show him how you sit? Ready? Sit. Good girl. I'm glad she did that the first time. But we're going to go over the worksheet from yesterday. I just kind of wanted to show you a little bit around my house in my uncut grass. Part of quarantine means I'm not going to cut my grass all the time, and that's okay. But I'll get to it soon. So, anyways, let me go over the last worksheet with you guys. The two questions I got were on number 7 and number 8. So let's go over number 7 first. Thank you for those who are asking questions. And I also realized that the last video I posted wasn't working. So anyways, hopefully we're going to get this all figured out. I'll start posting to YouTube. I feel like YouTube is more of a reliable source than how I was posting just straight from my drive. So Diana asked, how do I do this using the shortcut method? And for those of you who don't know the shortcut method, actually I just learned the shortcut method a little while ago. So you take the opposite of this guy. So you take the opposite of the second term of the divisor, and we're going to put -1 here. And you can also think of this as adding a 0 there. I'm going to add a constant because we're going to write down the coefficients. So you can think of this as 1x squared minus 1x plus 0. So we're going to write those down: 1, -1, and 0. And so the way this works, from what I learned from the YouTube video that Nana shared with me, is that you bring down this 1, and -1 times 1 is going to be -1. So I went in this order. And then I add those two terms. -1 times -1 plus -1 is -2. And again, I multiply -1 times -2, which is +2. And so, and then I add those, and that's going to be 2. And so I know that when I'm dividing, it's going to be 1 less. The first term is going to be 1 degree less than what the degree of the numerator. So I know my first term is going to be x to the power of 1. So I'm going to take this coefficient and the coefficient of that is 1, but in math we don't write a coefficient of 1. And then my constant is going to just be -2. And then this guy right here, this is my remainder. So I'm going to just add 2 over x plus 1. Okay, and so in other words, this guy right here simplifies. I don't know if it's simplified, but it can be rewritten as x minus 2 plus 2 over x plus 1. And so again, you know there's a slant asymptote when the degree of the numerator is exactly 1 more than the degree of the denominator. And so I know there's a slant asymptote, and truth be told, you can really just take this guy and call that your slant asymptote. That's a shortcut. And why do I say that? Because if I look at the ratio, which is just this part, I know that as x approaches infinity, this part is going to be equal to 0. And how do I know that? Well, if you imagine your x getting larger and larger and larger and larger, that fraction is the denominator is going to get larger and larger. And as the denominator gets larger and larger, that approaches 0. And so just the first part, y equals x minus 2, that's your slant asymptote. I can also show you algebraically why this fraction gets closer and closer to 0. So if I multiply top and bottom by 1 over x, I'm going to get something like this, which reduces to 2 over x over 1 plus 1 over x. And as x approaches infinity, as x approaches infinity. This is going to approach 0. This is going to approach 0. And what I'm left with is 0 over 1, which is just 0. So again, that's just kind of showing that this fraction right here is going to approach 0 as x gets bigger and bigger. And what's that tell us? That tells us as far as asymptotes go, we can disregard the ratio and we can just take this guy. So that's my slant asymptote. And I also have an asymptote where, let me erase this, where the denominator is 0, and so I know that x equal to negative 1, that's also a vertical asymptote. So there's two asymptotes there. Let's move on to number 8. Actually, let me show you a visual of number 7. And we're lucky enough to have that guy already graphed. And so we get this kind of weird, funky looking shape. And you can kind of tell that there is a slant asymptote at the line y equals x minus 2. So it'll approach that line, but it'll never touch that line. There's also another asymptote that I didn't graph at x equals negative 2. Let's go to my other tab. Graph the function y equals x squared plus x minus 6 all over x plus 1. Well, I'm going to just pull out the information I know right away. Right away, I know that there is a vertical asymptote at x equals negative 1 because it's undefined there. Let me just go ahead and rewrite this. I'm going to notice right away that I can factor this guy. So that's y equals x plus 3, x minus 2. How did I know it's 3 and negative 2? Because they multiply to negative 6 and they add to 1, which is the coefficient of x, all over x plus 1. And you might be asking yourself, well, why did you do that? Or asking me, why did I do that? Well, that tells me some critical points. That tells me that there's a point at negative 3, 0, and there's also a point at 2, 0. In other words, when I plug in negative 3 and 2 for x, I get the outputs of 0. So negative 3, 0, that's going to be part of my graph, and 2, 0, that's going to be part of my graph. But since the exponent of the numerator is exactly 1 more than the degree of the denominator, I know there's a slant asymptote, and I can find that using synthetic division. For this example, I'm not going to use the shortcut. I'm just going to use the other method, but feel free to use the shortcut. So I have x plus 1. I can tell that's not going to be enough room. I apologize. Oops. What am I doing? 6. And so I know this is going to be x because when I multiply it out, I get x squared plus x. I subtract those two. Those cancel. Ooh, these cancel as well. And I'm just left with negative 6, which is my remainder. So this is going to be minus 6 over x plus 1. I'm going to rewrite that. X minus 6 over x plus 1. And from the previous example, we know that since the degree on bottom is bigger, we know that this guy right here is going to approach 0. This is going to 0 out as x gets bigger and bigger. And so we know our slant asymptote is actually the line y equals x. Yeah, I hope that kind of made sense, that our shortcut is just to take the part that's left and kind of disregard the ratio because we know that's going to go to 0. So I know there's going to also be an asymptote at the line y equals x, which is this guy right here. And using the 2 points that I already graphed, I know that my graph is going to go through those points. So it's going to look something like that, and something like that. And I can double check it on Desmos if I'd like. And sure enough, I do get something like that. And if I graph my asymptote of y equals x, sure enough, it approaches. So anyways, I hope that was useful. Sorry that the last video didn't work very well, but we're kind of figuring it out as we go. Cool. Thanks, guys. Stay safe out there. Socially distance yourself. Stay woke.